Hello there. Today we'll be doing sort a linked list. Given a singly linked list of integers node, sort the nodes by their value in ascending order. We'll be doing about 100k nodes. So the first way we could do this is O of n and O of time and O of n space method. This is just converting the nodes into a list and then sorting the list and reconverting it back to nodes. It is a rather quick process. I think it's much more optimized than the O of n space and O of n time and O of 1 space. So let's check this one out first. So while node nums dot append node dot value. So we create an array. I'm going to append each item to the array. Once that is done, we do a dummy node set to a new linked list, and do nums.sort, sorting the linked list, and for num in nums, we do current.next equals ll node num, and continue the process until we get to the end of the list. We instead of current, we just say tail. I think tail would be a better word. This is the tail end of the item. And return the dummy.next. This should work. Oh, we have a runtime error. Oh my goodness. Returns outside the function. Oh, I see. Def solve self.node return run and submit. Perfect. Very fast. Very easy. Okay, I'm gonna need a lot more room for the second part of this. This is gonna be really intense in terms of code. So what we're gonna do is own of 1 space and not use any extra space by creating a whole brand new linked list and array and everything. Okay, we're gonna use the same items from the linked list and reorder them in a way so that we can return a sorted linked list without using any additional space. To do that, I'm planning to do a merge sort by moving the linked list around. So what I mean by that, let's take a look at the example. 14, 13, and 10. What we're gonna do is cut the list in half, let's say 14, 13, and then 10, splitting the list in half. Then we're gonna split it again until each item is a single item. Once we do so, we can merge the left and right list together to get an ordered list. So let's say 14 and 13 different lists. And we go for the smaller item and we merge that to a dummy node and 14, and then we send that out. Then we merge that with a 10 here, and given that 10 is the smallest item in this list, so we'll do 10. Of course, that right list is run out of items, so we do 13 and 14, and return this merge list back together. So we do several operations. We do a split list, and we do a merge. Of course, we split right down the middle every time to get that log n time, n log n time type like time complexity. Okay, so we're gonna do this and create all these functions and run it. So what we're gonna do is we're gonna create two functions. One is gonna be called definition of sort list, and the other one's gonna be merge self list 1 and list 2. Or we could call it left and right. I think that might be better. Left, right. All right. And we're going to just return our sort list algorithm with our node. Okay, so let's get down to our base case. Our base case is if not node and node not or not node.next. The reason we want to set this as our base case is because once we hit a single item, or no item in this case, we want to just return that immediately. So return the node. Alright, so next thing we're going to do is split right in half. We split this in half so that we can merge it later. The way we split this in half is a very common way of doing this, and I learned from other users. This is the fastest way I can see, the most like seamless way of doing it. For now, if you know of a way that's better, please comment about that, because this works, it handles all the cases very well. So like, let's say 2 items, right? And we have a slow and fast. Done, handled. 3 items, handled, in the middle. 4 items, handled, it's in the middle again. 5 items, right, handled. 6 items, handled, right? It splits it right down the middle every time, every time. All right, so next thing we're gonna do is take that pointer, point it, take that next item, start the list here, the second half of the list, and set this one to point to none. That way we can split the list properly. Alright, so now we can separate the 2 lists in half and keep separating them two using recursion. Perfect. And we need to get some more room and start deleting some of this comments. So we split the list in half, and we're gonna do a merge now after recursively splitting these all the way up until like the last item, and they will keep merging back together now. So we return merge, self.merge of left and right sides. Once we merge everything back together, we should have a sorted list. So that's done. Let's merge. So merging, if like so we want to create a dummy node to start our like our order. So while list 1 or left and right, if left dot value is less than right dot value, of course we're going to set this tail.next equals left, and then left is equals to left dot next, and otherwise we're going to move the right side. Tail dot next is equal to right side of the list, and right equals right dot next. After all of this is done, if left, then we're gonna continue. Oh wait, one more thing. Forgot the tail equals tail dot next. That is super important. Tail dot next is equal to left. Else tail dot next is equal to right. This takes up the remainder of the list, and we return dummy dot next. And with that, I think we have completed our problem. And this is a bit of code, not too much, and let's run it. Oh, we have a syntax error, line 7. Run it again. Oh, another error, 43. The comments, let's just comment that out. All right, run it. Okay, more errors. Sort list not defined. Right. Oh, what happened? What happened? Ah, right here. Run. All right, accepted. and let's submit. And perfect. It is rather slow. Of course, it's not optimized, and there's a lot of moving parts, assigning of things, but we've done it in O of one space. So that's all for this problem. I hope you enjoyed the video. Please like and subscribe. And if you have any questions, comment below. And if you want to see more, look at the description for a link. And there will be a lot of content about iOS and algorithms. So thank you very much, and have a good one.